Hello friends, this is David Quartiers, co-founder of Arduino. I'm here today again at the very cold Sweden to have the LiveCast, the Arduino LiveCast Season 2, Episode 9. And this week we're going to talk about this. We're going to talk about the ultrasound sensor. There's many types of distance sensors. There's infrared sensors, there's ultrasound sensors. In particular, we're going to talk about this one here. The idea was to make an assistive device that will give you information as you're moving around and will give you data on how far you are from different things and so on. But we're going to add some excitement to it because, as you know, if you're following the livecast, last week our social media expert decided to ask people what they thought about me wearing an interactive beard. So I did actually make an interactive beard. So I'm going to mash up today the thing we prepared for the livecast with something I just improvised half an hour before we started. And as a way to heat up the conversation, I want to show you very quickly what it is that I've been preparing. So this is it. I prepared an interactive beard and I put it together. It's made of a bunch of neopixels, individual neopixels. Maybe I can just start the video earlier on. Here you see I'm just having a bunch of neopixels and I prepare the wires and solder everything and so on. So this whole process took me about 45 minutes, more or less. So I prepared 6 interactive NeoPixel LEDs that I will just stuff into my beard and try to sing you a Christmas carol. But before we make it into that, let's talk about why we're here. As you know, my 2 tiny angels, Josephine and Carl, help me out on a weekly basis preparing relevant topics that teachers from all over the world ask about because they want to know more in order to include them in their classes. So this week, and 1 second, I will just turn on the chat here so I can follow the chat conversation live on the YouTube video. This week, there was a discussion about what if we explain the ultrasound sensor. We explained this thing a couple of times in the past, but why not once more? And we try to bring it up in a special way by building something a bit special, like a standalone device. And we made a standalone device, and let me just show you this thing with my top camera that you see. So we made, the guys prepare a standalone device that has an Arduino Uno. It's going to run on a battery, has an LED, an ultrasound sensor, and a piezo speaker. So we'll be making some noise. As usual, we've prepared a presentation, and here we go. As you know, this livecast is actually sponsored by the eCraft2Learn European Research Project, a project that just came to an end but keeps on sponsoring some of these livecasts that are aimed at helping teachers being inspired when they build new projects. And this particular project, we're going to work with the Arduino Uno. We will use a breadboard to put our components, an ultrasound sensor. This is the S02E09, which is a very common and extremely cheap ultrasound sensor you can find around. Here you have it in a bigger detail, and a piezo speaker, and a really big 10 millimeters 5-volt LED that we're going to use to display that we're close to something, as well as a 9-volt battery to power up the project. As you know, the Arduino Uno is not exactly optimized for battery life, so we keep it not connected until the moment we're going to run it. And directly after showing you how this works, what I will do is that I will hack it and I will connect it to my beard. So depending on the distance to objects, my beard will flash in different colors in the rainbow. It's going to be beautiful. And it's going to be Christmassy as well. So we need some wires, and this is the way the circuit looks like. We have the Arduino Uno is connected to the ultrasound sensor with 2 pins, as well as power and ground go to the ultrasound sensor. We have the LED and the piezo speaker. A relevant thing about the ultrasound sensor, because we explain this every time, is that it has 2 different cylinders. There are 2 transducers. One transducer is meant to be used to send an ultrasound burst, and the other one is meant to be receiving an ultrasound burst. I will just open it up and show it to you very close. There you go. So on the back of this sensor, there is a lot of chips. There you go as well. So these guys are responsible for what we call a conditioning the signal. So they they take the 5 volts from the Arduino. Arduino sends a very tiny pulse, and that's transformed into a signal that has enough power to go through this transducer that produces a burst, which is a signal, a train of pulses that is sent out in the air, that travels through the air, bounces against an object, comes back, and then the other transducer receives the signal and translates this signal into a pulse that has a certain width, and that width is determined by the time of flight, which is the amount of time it takes for the signal to go and come back. And that width actually can be then translated into distance. It's a very simple algorithm because we know the speed of sound. As you know, the speed of sound is more or less 340 meters per second. Well, actually depends. In this very cold environment, probably it goes a bit slower, like 339,9999 or something like that. I say this as a joke, but the sound speed, or the speed of sound, varies with humidity and some other things. So ultrasound is very sensitive to humidity for two reasons. One is because the sensor can get humid and it will not respond the same way, but also because the actual signal will not travel at the same speed. Okay, so this sensor has 2 pins and therefore 2 wires on it. One is to trigger the signal, so Arduino needs a pin to send a pulse to the ultrasound sensor, and another one to receive the echo back. And we can check this out if we take a look at the Arduino code. So let me just turn on the IDE and show you this. Here you see the Arduino code, and you see we're going to use 2 pins, and in this particular case, pin number 13 is used for triggering, and pin number 12 is used for the echo. And we have pin number 8 for the piezo speaker, because we will be playing a sound whenever, or based on the signal, on the distance to the object, which is actually on the signal we get from the air. And the LED is connected to pin number 3. All of the pins are outputs except for the echo pin, which is going to be receiving the signal back from the ultrasound. And this particular example is using the serial board as a way to check the distance. We're going to just first see how it works, and then we will connect the board to the computer to get the opportunity to see what kind of information is being sent through the serial board. And as you see here, what it's doing is that depending on the distance, it's going to be playing a tone or a different tone on the piezo speaker. So this is going to give us a very clear indication on how far we are to different objects. So let's just turn it on. If I change camera here again, I have it here. I will plug it in. We will check it out. And the next thing we will do is to hack it, so we can use the interactive beard controller. So here it is. I will bring it closer to the microphone so you can hear the sound. So it's very clear how it works. It's basically a device that it's responding to obstacles. So you could eventually wear it somewhere and could tell you how far you are from something. So it's kind of like an assistive device. You can imagine multiple scenarios on where to use this device. But what matters really is that it's very simple to produce the code and to wire this up so it could be used in class. So we've seen multiple projects in different schools in the world where students make very clever adaptations. So this very simple example to, for example, create intelligent or smart canes for blind people or people with visual impairment in general to navigate spaces. So you can do it with sound, we can do it with a vibration motor that can give them force feedback, or wherever other mechanism you could imagine. You could have multiple of these sensors, and actually this ultrasound sensor is used widely in robotics. Okay, but this was about the serious stuff. Let's now talk about the fun stuff. So the fun stuff is how to get that code that we just saw connected to my interactive beard. Here is my interactive beard. My interactive beard is made of a bunch of NeoPixel LEDs that are wired up together. And as I say, I soldered this thing just some minutes ago. So I'm gonna get the beard on just for the purpose of making something fun for Christmas. And oh my God, this is hard to do. I've never did this before. I'm not used to this, so I want to try to make it real fast. So here you go. This is not gonna be the best moment in my life, I think. So second, here you go. And again, this is strictly live. So maybe you may be watching this video later, but this has not been rehearsed or anything. So I'm been coding this live just some seconds ago, just before coming into the shed to try it out. So we connect it again here, and okay. If I have had a different kind of wire, like a black wire, I would have definitely helped, but I just didn't have it in the lab because it was very improvised. So it's always good to have different kinds of wires. The one thing that this wire is thinner than the typical jumper wire that is used for projects. It's important to have those kind of wires if you want to like make nice projects later on. And I'm not gonna use this one. I'm gonna use a different one that I have around here just to make it very quick. So I need to plug in power, ground, and a signal pin. So I've made this specially for today. So, oh my God, which one is ground now? Because I didn't have a black wire. Oh, this one is ground. So I mark with a black marker, and the problem is that things got erased as I moved things from place to place. So, oops. Yeah. So this one is ground. This one is 5 volts for the NeoPixel LEDs, and the last one is signal, and I have to bring it to the other side of the, for example, pin number 8. So the one thing that you should definitely never do is to plug in your body to something that is plugged to the mains. In this particular case, you should be aware that this Arduino board through the USB cable is going to be plugged to the mains of my shed. So if you make any kind of wearable projects, you should never wear anything unless it's working on batteries. So the thing I'm going to do right now is not recommended. So please be aware, this is my full disclaimer for you. If anything happens to you while doing this experiment, don't say I didn't tell you first. So I made the cables a little bit short, so I'm having some issues now. So this is I have to hold it in my hand because the cables are short, but this is black now. So I'm gonna just move on the Arduino IDE. Here it is. And I'm gonna open one of the NeoPixel examples. This is very simple. So I go to examples, and since I've been making some NeoPixel examples in the past, this is super easy. NeoPixel, and I'm gonna take the simple example. Here's a simple example. It opened a different window, sorry. I will just bring it on this window. Here you have it. I have connected everything on pin number 8. And I only have 6 LEDs in the beard. So let's first check whether this works. This will turn my beard green. Let's see. This sounds so weird. This Arduino Uno. And for some reason, oh, I think I happen to take the only Arduino board in the whole shed that might not be operational. No, here it is. I just hadn't plugged the USB cable properly. So I upload this code to the board. It's compiling, and if everything goes as expected, these should shine green. And I should not get electroshocked. Okay, it is not working, which means, oh, I just took the wrong pin. Oh, there you go. Okay, fantastic. So next thing we can do is that in this example, we're having this delay that is just put here at the very bottom. So we'll just remove it from here and put it somewhere else. And I will add something a bit funny, which is just to randomize the colors. So I will just add that the colors are going to be randomized between 0 and 100. And you have to understand that right now I'm typing with just one hand while holding everything with the other hand. So I want to thank Carl and Josephine for these challenges that they have decided to put me into, because this is definitely something that I want to do on a weekly basis. And blue will be a random color as well. And here I will just say this to be R, G, and B. And re-upload the code. And now you will see how the beer changes color. Right? The next thing is just to make a very simple exercise of adding the Bluetooth, the ultrasound to the beer, so the beer changes based on the distance. But I will probably not make it in this livecast, just because of time. It's still uploading. And a couple of seconds. This is uncomfortable silence, as if everything was gonna fail. Actually, yeah, there is a glitch on my USB cable, so that's why it actually didn't upload. I will just hold it with the other hand. Yeah. I think I need to change cable for the next livecast. That will be after New Year's. But this time it seems to be working. And yeah, now it's uploading. And it's done. So as you see now, every half a second the color shifts to a random color. So as you see, it's very, very simple to make wearable devices and satisfy people's curiosity on the internet. So I want to thank you all for coming to the Arduino Livecast for the last 6 months. This has been the second season, and we will let you go, guys, until we come back from Christmas season. So the second week of January, we hope to see you all on the Arduino Livecast. Remember to subscribe to our program, and we see you soon on the internet. Thank you very much.